This is tutorial 8-1 in GIS tutorial workbook 2. In this exercise, we're going to be using the average nearest neighbor tool. Now, what this tool is going to do is it's going to determine if there's any statistically significant level of clustering or dispersal. And this is going to happen by measuring the distance from each feature to its single nearest neighbor, and then calculating the average distance of all the measurements. The tool then creates a hypothetical set of data with the same number of features and then places them randomly within the study area. Then it measures the average of these features and then compares them to the real data. Now, when the nearest neighbor index is returned, what it's going to do is it's going to show us the ratio of observed and hypothetical data. And if it's less than 1, it means that there's clustering, and if it's greater than 1, that means that it's more dispersed. We will also get a z-score, and what a z-score will do is determine if this is a random or if there is a pattern happening. Now, down here you might see that we have a confidence level. The most widely used confidence level is 95%. So I'm just going to go in and change that now. And with that confidence level, if our z-score falls between negative 1.96 to positive 1.96, it means that it's just random. If it falls outside that range, it means that it's either that there is some pattern going on. And those numbers will change if you use a different confidence level. Okay, now on to the actual tool. Or the exercise, I should say, because there's some stuff we have to gather before we do the tool. And the most important thing we have to get is the area of our study interest, which is Battalion 2. So we're just going to open up the attribute table for that. And if you just look over here, you'll find the area of Battalion 2. And you just have to jot that down as a whole number. They also want us to look at the data we're looking at. We're doing EMS calls, which is, if you turn on this one right here, and we're just going to bring it down, you'll see that the incident calls fall right on top of the EMS calls. The reason that's happening is they did a definition query just to get EMS calls. And I'm going to show you what that definition query looks like. See, any incident type that is equal or greater to 300 but less than or equal to 322 is an EMS call. They just wanted you to know that. Okay, now that we know the area and what we're actually going to be looking at, we can use the tool. Now, they want you to use the search window to find the tool. I like to use Arc Toolbox because it lets you learn how to find it and what else is available. So you're going to go to your Arc Toolbox, you're going to open up your Spatial Statistics tools, and you're going to go to Analyzing Patterns. And you want the average nearest neighbor. This tool is pretty straightforward. You choose your feature, in this case, EMS calls. We want to use the Euclidean distance, which is a straight line as an aerial view. We do want to generate a report, and we do now know the area. Now, the report has been generated, but in order to get it, you have to double-click on this average nearest neighbor pop-up box. Now, say you didn't know that and you already clicked it off. you just go to geoprocessing and you go down to results and it opens it up. And we want to go to our current session, open up that, and messages is where our information is. Environment and inputs, that's not really necessary, so you can keep that closed. Okay, and what we're interested in is this information right here. So I'm just going to scroll this map over, and we're going to fill in this box as we go. Now, our nearest neighbor index is this right here, this ratio, this nearest neighbor ratio. So we're just going to put that number in. I'm just going to put all the numbers. If you want to round off, that's perfectly fine. Seeing that it's less than 0, that means that it's pointed more towards clustering. And we're just going to put our observed mean distance. And these I'm just going to leave as a whole number because I don't feel like writing out that many decimal places. And our z-score. Now it's important to put the negative sign in if you're ever doing a z-score. And this z-score shows us that there is a pattern and that it's not random. Okay, and with that done, now what we can do is we can actually look at this from a graph. If we just double click on this report file, it opens up in my browser, and here is our value right here, and it's showing you that yes, it is significant and that it is clustered. And if you scroll down, it gives you everything else. And this even includes units. It gives you your nearest neighbor ratio, your z-score, your p-value, and everything else. Now, the book also talks about showing this as a box plot. So we're just going to go through that real quick. We're just going to close that. And to do that, you just want to go up to View. You want to go to Graphs, and you want to create a graph. Graph type, box plot. We're interested in EMS calls, and we want our field to be FEE. Now, the book shows that there's a call ranking of 6. In our attribute table, there is not. It just ranges from 8 to 10. So it will not look like the book. We're actually just going to change the color of that to that. And that's what we would do. It's not too impressive to me, actually. But feel free to go ahead and play with the incident calls. That one will show you actually a better map. Let's actually go through and do that one real quick. Because this one will give us a better looking graph. Okay, there we go. This looks more like what they have in the book. And that's it for this tutorial.